Hello students, welcome to Showed Sir classes, and this question is from ISI M.MATH 2022 paper. The paper code is PMA, that is the object MCQ section. The solution has been prepared by the faculty members of Showed Sir classes. So if AN is given as, so let's write what is AN. AN is given as 3 plus minus 1 to the power n to the power n 4 to the power n is given, and then the power series we have to find. This power series summation of n equal to 0 to infinity a of n x to the power n. We have to find whether this converges, and converges at if and only if these four options are there. We have to find the correct option, the right option we have to find. So from here we can do this, that if we take this n to the power a n to the power 1 by n, so it will be pretty easy for, so it will be then 3 plus minus 1 to the power n by 4, right? Now which will be, this will be half if n is odd and 1 when n is even. Okay, so we have the region of convergence, it will be R equal to this limit n tends to infinity, so we can write it as an to the power 1 by n. So if we put n equal to infinity, so it will give R equal to 1. Okay, so the power series, so we can say that the power series is convergent on minus 1 comma 1. So which of this for x in the interval minus 1 comma 1, this is an open interval, and at x equal to 1, x equal to 1, we have this summation of an is divergent, and at x equal to minus 1, it will be summation of minus 1 to the power n an, it will be divergent. This x equal to minus 1. Right. So now our final option, so we have got the correct option. This is in our case for question number 19, the correct option is D. So D, where x is an element in the open interval minus 1 to 1. Question number 20, so consider the sequence we have been given. The sequence is Fn, and where n equal to 1 to infinity, sequence of function on the closed interval, that is minus pi by 2 to pi by 2, given by the Fn is given as Fn x is given as sine of x to the power n cos x. So we have to find the sequence Fn will converge uniformly on which of the following options is there. Out of the four options, we have to find on which the sequence will converge uniformly, on which of the interval. So here we can say that if we consider that fx equal to 0, we can find the limit of the function. So if we do this f of n prime, the first derivative, okay, so we can not at this moment. So if let's do the first derivative of f of n x, so it will give n of s sine of n minus 1 x cos square x minus, so cos x will be there, sine x, so sine of n to the power sine to the power n plus 1x it will be, right? So now if this is equal to 0, so we have n of sine of n minus 1 x cos square x equal to, okay, so let's write this in this manner. So if we consider it as 0, so this minus of sine of n plus 1 to the power n plus 1 equal to x equal to 0. So from here you can get n of sine n to the power minus 1x cos square x equal to this sine of n to the power plus 1 x, right? So which is nothing but this n of cos square x by equal to this sine square x, or we have this cos x is equal to plus minus 1 by root n sine x. So when n is large, okay, when n is large, then we have the sine of this tan of x is equal to plus minus 1 by root over n, or for n large we can say x equal to plus minus 1 by root over n. So this is an approximate value. Approximate. So fn, here you can see that as n tends to infinity, that mod of fnx is equal to this, then we have this mod of 1 by root over n to the power n. As n tends to infinity, this fnx tends to 0, right? So f of n tends to 0 uniformly on the closed interval, that is minus pi by 2 comma pi by 2. So this is for the large n. So our option, the correct option here for the question number 20 is D. Question number 21, for any a which is member of this in the closed interval 0 comma 1, the limit of the sequence. So we have been given the limit of the sequence, that is x of n where n equal to 1 to infinity, where xn is given. So we have to find the limit of the sequence. Xn is given as 1 plus 2 to the power a plus up to n to the power a, not alpha, it is n to the power a divided by n to the power a plus 1. Okay, so here we can write xn as 1 by n summation of k equal to 1 to n k by n to the power a. So thus xn is integral 0 to 1 x to the power a. Now if a equal to 0, then this 0 to 1 1, it will be 0 to 1 is 1. Now if a equal to 1, then we have integral 0 to 1 of x, which is nothing but half, and this is for if a equal to 1. Now if a is in this value, the range of a is between 0 and 1, then we have this integral 0 to 1 x to the power a. So if we integrate this, it will be 1 by a plus 1 x to the power a plus 1 1 comma 0, so which will give the answer 1 by a plus 1. So in our case, the correct option is for 21 is C, that is 1 upon 1 plus A, that is the limit of the sequence. Correct option is C.